Okay, this is the geometry lesson for 5.5, indirect proof. So we're going to use indirect reasoning to write proofs. So this is one of my oldest lessons ever, which just takes screen prints from the textbook, but I think it works fine. This is actually the getting ready section of the textbook, but this is one of those Sudoku games, which is kind of fun to do. Right, the goal of this game is to fill in the empty squares with numbers. The numbers 1, 2, 3, and 4 must appear once in each row and once in each column. Copy and complete the games on a piece of paper. So we can actually do them right here, or you can copy them and do them on a piece of paper. But this just uses indirect reasoning, right? In indirect reasoning, all possibilities are considered, and then all but one are proven false. So if we look, let's see, we have 1, 2, 4. If we look at this row here, we can see we need a 3 and a 4 in either one of these. But we already have a 4 in this column and this column. So the only thing left here for this space is a 4. Right, so all possibilities are considered, and then all but one are proven false. So we have a 1, a 2, and then a 4. This has to be a 3. Right, and then we can see here we need a, we have a 2 in this row, we have a 2 in this row, we need 1 in this row, but there's already one, or sorry, this column, there's already 1 in this row, so this has to be a 2, which means this has to be a 3, which means this has to be a 1. And then, this has to be a 3, this has to be a 2, 3, 4, 1. Anyway, that's kind of how it works. And so that's our introduction to indirect reasoning, when all possibilities are considered and then all but one are proved false, and then the remaining possibility must be true. So feel free to play game B on your own. It is fun. So a proof that involves this kind of reasoning is called an indirect proof. And then often in the indirect proof, a statement and its negation are the only possibilities. So that when you see that one of those leads to a contradiction of a fact that you already know it's true, then you can eliminate that possibility. And then for the other reason, so the other one has to be true. So this is called either proof by contradiction or an indirect proof. Okay, so when we write an indirect proof, you first see what you're going to prove and then assume that the opposite is true. Right, and then when we show the contradiction, then we can say that then the opposite has to be true. So the first thing we need to do is state as a temporary assumption the opposite or the negation of what you want to prove. And then the second step is to show that the temporary assumption leads to a contradiction, and the third is you can conclude that it must be false and what you want to prove must be true. So the first step in writing indirect proof, let's look at those first. This problem 1 says, suppose you want to write an indirect proof of each statement. As the first step of the proof, what would you assume? So here we have an integer n is divisible by 5. And so the first step, it says state as a temporary assumption the opposite of what? So let's, the first step we would assume temporarily, temporarily. Sorry, I can't spell. Okay, temporarily, that n is not divisible by 5. Right, so that's the negation of it. If it's divisible by 5, the opposite of that is not divisible by 5. And that's all they want to know, step 1. And here it says you do not have soccer practice today. Okay, so let's assume temporarily that I do have soccer practice today. Okay, so what's the opposite of what you're trying to prove, right? I'm trying to prove I do not have soccer practice today, so the opposite of that is that I do have soccer practice today. All right, so try this one on your own. Suppose you want to write an indirect proof of each statement. As the first step of the proof, what would you assume? That in A, we're trying to prove that triangle BOX is not acute. And then in B, we're trying to prove that at least one pair of shoes you bought cost more than $25. So press pause, write your first step, and then check back for the solution. Okay, hopefully you found in A that the opposite of not acute is acute. And the opposite of at least one pair of shoes you bought cost more than $25 is that no shoes I bought cost more than $25. Okay, and then for problem 2 here, we're going to identify contradictions. So we're moving on to the contradiction part of this indirect proof. So which two statements contradict each other? So here we're saying FG and KL are parallel. This one says they're congruent. And then this one says they're perpendicular. So can they be perpendicular and parallel at the same time? No. So these two statements contradict each other. Okay, so try this for the got it. Which two statements here contradict each other? The triangle is acute, the triangle is scalene, and the triangle is equiangular. Scalene means all three sides are different lengths. Equiangular is all three angles have same measure. And acute means that all angles are less than 90. Okay, so try to figure out which of these two cannot be true at the same time. And then check back for your solution. Okay, so I started with this one, right? Equiangular, that means all three angles have to be equal. But remember, there is that corollary to the isosceles triangle theorem for the equilateral triangles. If they have all three angles the same, then it's an equilateral triangle. So all three sides have to have the same length, which contradicts with this one that all three sides are different lengths. So it can't be scalene and equiangular at the same time. Hopefully you got that one. And then moving on, problem 3. All right, so here we're going to write an indirect proof. So here, given that the triangle is scalene, we're going to prove that A, B, and C have different measures. Okay, so we're going to start this proof by assuming that what we're trying to prove is not true. Okay, so we're going to try to prove this by contradiction. So let's assume temporarily that angle A equals angle B. Measure of angle A equals measure of angle B, right? We just have to pick two, right? And basically the opposite of this is at least two angles are the same. That's the negation. Okay, so let's say this is measure of angle A equals measure of angle B. That's our assumption. Then, right, in our triangle, if angle A was equal to angle B, right, then AC has to be congruent to BC by the isosceles, or the converse of the isosceles triangle theorem. Right, but this is a contradiction to our given. And so since we're given that ABC is scalene, and then in order for this negation to work, AC has to be congruent to BC, then therefore angle A, angle B, and angle C all have different measures. Okay, so we take what we're trying to prove, take the negation of that, assume that that's to be true, and then continue our proof with that assumption until we can show a contradiction. And once we show the contradiction, then that proves that the only other thing that can be true is what's left. And so that's how we prove it. Okay, so let's try this another one. I'll do this one. You don't have to do this on your own. Okay, so here we're trying to prove that x is equal to 6. Sorry, x is not equal to 6. So let's assume temporarily that y does equal 6. Okay, and so 7x plus y equals 70 is given. Let's plug in 6 for y. That's substitution. Let's divide both sides by 7. So we get x plus 6 equals 10. That's division, property of equality. Let's subtract 6 from both sides. So we get x equals 4. That's subtraction, property of equality. And there's our contradiction. We were given that x equals 4. So our x does not equal 4. But we have here that x has to equal 4 in order for x to equal 6. So because of this contradiction to the given, right, therefore y cannot equal 6. So that is how an indirect proof works. Do we want to do any of this? No, let's not do any of those. Okay, there's your homework. Try that on your own, please. Enjoy.